Time for us to see where equal cost load sharing can serve as a benefit, as it usually does, with RIP. We saw some load balancing going on, and we chatted about it a little bit during our auto summarization lab. And load balancing wasn't working in our favor, but that was more because auto summarization was left on. In this lab, as with most production networks, it is off. And I want to show you not only see load balancing as far as the routing table goes and what you should expect to see, but I want you to see it in action. I've got a cute little way to test load sharing and introduce you to the traceroute command at the same time. But first things first, you can see what I've done here is taken our original serial network, our original frame network between routers 1, 2, and 3, 172.12.123.0/24, and I've added a 172.12.23.0/24 subnet. That subnet is being used on routers 2, 3, and 4 on their fast Ethernet interfaces, and also router 4 is running a loopback, the all 4's IP address there with a /24. The entire network is configured for RIP. You've seen these commands over and over, so I've gone ahead and done that for you this time, and it's the usual, the network commands, version 2, no auto, and you're ready to go. So if we take a look at this though, router 1 actually has 2 loop-free paths to send packets when it sends packets to loopback 4. The packets could go to router 2's serial interface, then router 2 would route them out its fast Ethernet interface, router 4 would receive them on its fast Ethernet interface, and then of course the loopback being connected, there's no problem there. The packets from 1 to 4 could also leave router 1 and go to router 3. Router 3 receives them on a serial, sends them out the fast Ethernet interface. Router 4 receives them on its fast Ethernet interface, and then the packets are at the loopback. So it would be kind of a shame to use one of those paths exclusively and just leave the other one alone, because it is more efficient if we do some kind of load balancing, hence the name equal cost load balancing, because it's much more efficient to use both paths and send about roughly half the data over each one than just to use one path exclusively. So that's what we're doing here, and actually the great thing with RIP is we don't have to lift a finger to make that happen with equal cost load balancing. Let's go ahead and I'll send some pings over to router 1. Over to router 4's loopback, and you can see we can ping it. But ping is a great place to start a connectivity test. It's a great place to start a lab, and it's a great place to start your troubleshooting. Yeah, so I'm leading up to something, right? Well, what I'm leading up to is it's a little bit limited, because ping tells you if you have connectivity. Ping tells you if you don't have connectivity. It showed us during the auto summarization lab. It can even tell you that you have some connectivity, but not as much as you want. The thing is, though, we have no idea what path these packets took to get to 4. We have absolutely no idea. And if we'd like to test our load sharing, maybe we could use a close cousin of the ping command, the traceroute command, to make that happen. Before we get to that, though, let's take a look at our routing table. And actually, since we've been running show IP route RIP a lot, you're used to that command. You can also use show IP route for a network number and put it in like that. And it's going to show you how many subnets it knows about, redistributing via RIP. They're known via RIP. And you can see exactly what we would see in the RIP routing table or in the IP routing table as a whole. And we have the usual RIP entry. There's 4440. That's the one known subnet. We know the administrative distance. We know what those numbers are. The AD followed by the metric. And yes, I did tell you again. Followed by the next stop IP address, followed by the last time we heard about these routes, followed by the local exit interface. But why do I have 2 routes here? Why do I have 2 of those? Well, you're saying, well, Chris, because it's equal cost load sharing. And that's exactly what it is. With RIP, you're much more likely to have an exact match in your route metrics at the beginning of a lab or a production network as you will with EIGRP and with OSPF, just because EIGR and OSPF's metrics are much more complex. So the numbers, frankly, are going to be a lot larger. You're not going to be dealing with one number. You could be dealing anywhere from 2 numbers to literally 8 or 9 numbers, maybe even more. The metrics get pretty big. But here with RIP's saying, hey, these paths are absolutely equal. I have 2 paths I'm getting via my updates, and I'm putting them both in the table because they have equal cost, And now we're going to send roughly half of the data going to 4440 is going to go through 123.2 over at router 2. The other half, roughly 123.3. I say roughly because it's rare that it's going to be exact, but it's going to be pretty close. Now, what if we wanted to change that a little bit? And how do we know how many paths RIP will load balance over by default anyway? I believe I mentioned that, but I'm going to mention it again. It's 4 by default. And if you run show IP protocols, which seems like we always come back to show IP protocols, that's what this maximum path is referring to. That really doesn't give you a good description. Everything else in here is, automatic network summarization is not in effect. Here are your routing information sources. Here are your update timers. Everything is explained so beautifully. And then in the middle, you got maximum path 4. Well, maximum path for what? So it would be a good idea for us to know, as we now do, that that is the maximum number of paths we're using right now for equal cost load sharing, and that's by default. Now, if you want to change that, I'll show you how to do that. The name of this command will not surprise you. Maximum path. So if you've got, a lot of RIP paths you want to load balance over, you could certainly raise that. You may have reason to lower the number. Usually people just leave it right at 4. Notice, though, that you don't have a 0 here. And you usually see a 0 anytime you see numbers listed in iOS help, simply because usually when we put a 0, we're disabling something or we're turning a timer off, something like that. We don't have that here. But if for whatever reason you wanted to disable equal cost load sharing, just set the maximum path to 1. Can't set it to 0. You can try all you want to. See? And it tells you exactly where the invalid input is. You can't set that to 0, but you can set it to 1. Now, just a couple of words here before we start testing that load balancing, and it's about the maximum path command. Cisco hardware, different versions, different iOS versions, they offer a range of maximum values for the maximum path command. You'll never be able to set it to 0, but the maximum is not always going to be 32. That's more of a real world thing. I just want you to know that because I don't want you to be on another router model. It's like, wait a minute, this is 16 and this one's 64. What's going on? It's not always going to be 32. Again, I just put a note on the board, but something I mentioned while we were there. If you want to disable equal cost load sharing for any reason, just go ahead and set that value to 1. And actually, we're going to stop right here for a moment. When we pick up on the beginning of the very next video, we're going to do some trace routing, not just with the Cisco router, but maybe with a PC as well. I'll see you at the next vid.